decimals out for this, but we're going to get started in 2.5. I'm going to tell you the last three sections here in chapter 2, they're all going to deal with quadratics. Okay, so 2.5 is titled Transformations of Quadratic Functions. Transformations meaning how are we going to move them, all right? So the idea today is this. If we're dealing with the transformation of quadratic functions, anybody remember the general form for the parent function of a quadratic?
It's x squared.
Yep, y equals x squared. Good. All right, so we're going to be thinking that, what kind of shapes do they make then when you graph them? A U shape, okay, a parabola. And I'm just going to throw this in here real quickly. I'm going to go ahead and graph my parent function because we're going to do some transforming of it today. And the thing I think you're going to find out today is we've kind of done this stuff already. We've kind of talked about this already. I think this is going to make perfect sense in terms of what we're doing. But when I get into Desmos here, well, where is Desmos? Where? There it is. Yep. Thank you. Okay, I'm going to put in y equals x squared just to start. We all know what the parent function for this graph looks like the following. Okay, U shape. Where's the vertex at in that? 0, 0. Okay, so a vertex is simply going to be the, either the highest or lowest point. Okay. Now we're going to talk about this here a lot today and how things are transformed. Some of it's very simple. Some of it's going to get a little complicated, and it's going to be okay. I think if you remember all your rules from what we did in sections 2.1 and 2.2 about transforming stuff, I think you'll be okay. All right. All right, I need a volunteer to read an essential question for me. How are we working with transformations of quadratic functions? Someone to read that for me? Thanks, Liam.
You're welcome. How do the constants a, h, and k affect the graph of the quadratic function? G of x equals a parentheses x minus h to the second power plus k.
All right, very good. So we're trying to ask, what are these values, a, h, and k? What do they do to our function rater? So again, we understand that we're dealing with what family again, kids? Quadratics. The thing you need to understand today is this. These a, h, and k that they're referring to right here, they're just numbers. Okay? They're just numbers. So if you guys think back to how do things move, like how does something move up so many units? Or how does something move left or right? Or how is something vertically stretched? Or how do we shift things horizontally? Or how do we shrink stuff horizontally? Those kind of rules might come in handy for you today, okay? In fact, your 2.1 notes might be something, I'm not going to tell you you have to, but you might want 2.1 stuff out to help with this today, okay? All right, in order to answer that question, you need to be able to describe transformations of quadratic functions. And then we also need to be able to write transformations of quadratic functions. So at the end of this right here, this is what I want you to be able to do. Okay? I want you to be able to describe transformations and write transformations for quadratic functions. So let's get into the vocabulary. What is it that we're really doing today? Volunteer to read my quadratic function definition.
A function that can be written in the form of x equal to a parentheses x minus h parentheses squared plus k.
Okay, so as an example, you might have like 6 times x minus 3 squared plus 7. Okay? What's your a value in that, kids? What's the a value in that?
6.
What's the h value? 3. Okay, what if that was a plus 3? What would your h value have been then? Negative 3. So it's kind of the opposite of the sign that's in there. What's the k value? 7. Okay. You might want to jot this down over by this here for quadratic function, okay? But your a value in this right here, that's going to affect things vertical. It might be a vertical stretch or a vertical shrink. So I'm just going to put the word vertical in there, and you might want to write vertical stretch or shrink there. Does that make sense? So that a value in that formula is going to have a vertical stretch or a vertical shrink to it. Okay, so that's what that's affecting. Guys, when we talk about adding or subtracting something in parentheses, do you guys, when we add or subtract in parentheses, do you remember what that does? Left or right, okay? So the h is going to affect some kind of, how do I want to say this? Is it okay if I say horizontal shift? going to be a horizontal shift of some kind. And maybe for this one, this A is either going to be a vertical stretch or shrink. Anybody got a guess on what the plus K is going to do up there on the outside? Up or down. Why didn't I write that? H means move left or right. Why didn't you just tell me to do it that way, Belle?
Oh my gosh.
Jeez.
Dang it.
I can't read any of that anymore. Hopefully you've got it written down. What's K effect again? Up or down. Well, that's why I keep you around. You make things that are complicated very easy for us to understand.
What was I saying?
Just switch it.
K is which one?
A stretch and shrink.
No, with the arrow.
K is up or down, says stretch or shrink. After I moved everything here.
Whoop me if you want. Oh, I know that's German.
Okay. Because I'm just so used to brown.
I don't know what's so hard to read about that. It says stretch.
Oh, yeah. There we go.
Okay. All right, then K, you have it written in there. K is going to affect either moving it up or down. Okay. So guys, you know what a parabola is? A parabola is a U-shaped graph of quadratic function. It's either shaped like a U shape or an arch. In this right here, I'm just going to write down some cheater notes. A U shape always happens when you have some kind of a positive x squared. And an arch shape is going to happen when you have some kind of a negative x squared. Okay, so positive x squared is a U shape. Negative x squared is an arch shape. And we know that already.
Yeah.
And by the way, think about it. If I have a positive x squared, what does this negative sign do to your graph of the U shape? Flips it over, doesn't it? Okay. All right, the vertex of a parabola, simply put, it's either the highest point or the lowest point in the graph. So if I have a U shape, is the vertex the highest or the lowest point? If I have an arch for a parabola, is my vertex the highest or lowest point? Highest point. Okay. And then the next thing you need to understand then is this. If this is the form that we're going to talk about quadratic function, the form that we're specifically talking about, and this is very important, it's going to be vertex form of a parabola. Vertex form of a parabola is simply what we wrote up here. It's going to be a function of the form a times the quantity x minus h squared plus k. A cannot equal 0. It says the vertex is what, kids? H comma what? I'm going to draw something up here. Be careful on this. F of x is equal to, I don't know. How about 2x squared? Oh, I don't want to do it that way. 2 times the quantity x plus 3 squared minus 7. Okay? Now, I want you to understand something. If this is called vertex form of a parabola, and they say, where's the vertex for this graph? It says the vertex occurs at h comma what? K. All right, notice in here, hang on. What kind of sign do I have in here? In the original form, that's a negative. What kind of sign do I have right here? So my h value would really be what here? Negative 3. So the vertex of this graph is going to occur at, it's kind of the opposite of this sign. Negative 3 comma what? K. And the K stays the same, so you keep the negative 7. So the first one in this right here is kind of the opposite. The next one is the same thing. I'm going to put that function in here just to show you that this is true. Okay? So a vertex. What's a vertex again, kids? Highest or the... Okay, when I write a function in vertex form right here, we say the vertex occurs at h comma k. This h is kind of the opposite of this sign right here in parentheses. The k stays the same. Let's just look at this. You guys tell me what the function was here that I just wrote. Y equals what? 2 times parentheses x plus 3 squared minus 7. Okay, so our new vertex for this, where'd our new vertex fall at, kids? Okay, you understand that? Let me throw one up on the board. You tell me where the vertex is. Where's your vertex? Give me a show of hands, please. Hunter, what do you think? 4, 22. Love it. Okay, 4, 22 would be the vertex. Okay, how many agree 4, 22? Okay, so if you see that form and I say, hey, where's the vertex for this graph going to land? Do you need to graph it or can you easily tell now?
So it's just sorry.
Yeah.
So the x is just the opposite of what
Kind of the opposite of this one right here in parentheses, yep.
Oh, that's easy.
And the reason they do that, Sophie, is this. The question really becomes, what value would you plug in for x to make this whole parentheses 0?
Oh, okay.
It is what value? 4. That's why that 4 goes there. And that's why it's kind of the opposite of this right here. Okay. But you can only get away with that if this is in vertex form. You have to have an a value out front, an h value here, and a k value out there. Okay. Very good. All right. Very good. Let's move on this. Right? All right. Guys, I screwed up the typo. This x2 right here, that should be an x squared. And then you see where the parentheses are, x minus 1, kids? Mm-hmm. And then a 2 right behind it. This should also have been a square right there. Okay?
So 2 should be squared. Wait, what now? So like just the
So, like right here, see how it says x2? That should be read x squared. I forgot to raise it to a power here and here when I typed those notes in the other day.
Silly.
I know. Fire me now.
No.
Can I get fired from being a student?
No.
No.
Technically, no.
Carson, you were just giving me really, you just really scared me.
What's that?
You really just scared me.
What's that?
Basketball starts in months.
I know. I'm kind of worried about basketball this year.
Did you hear that? Basketball starts in months.
Sorry I make it so bad for you.
No, you don't.
But I may not be around much this basketball season. Huh? Well, I'm having some complications, Ellie, and I had a surgery this summer and it hasn't corrected it. And
Wait, you're not doing basketball?
I am, but the doctor wants to see me a week from Friday, and it sounds like I could be laid up from a week to a month, possibly.
Carson? No, I mean, who is our assistant coach going to be then? Who is this other coach?
Tiffany will take it. It'll be fine. Tiffany Reedy. You'll like her better than me. Trust
We're
me.
having a girl?
No, you won't.
Who is she?
Tiffany Reedy.
You'll
You'll know in a little bit. So.
Please be me.
Carson,
Please be me.
Yes.
send Maddie Bonner to the office for a second.
God, why do you hate me?
Why do you guys hate me? Wanted to get pulled out.
No,
I want to go my knee.
I see you want to. I don't like going to
Oh.
Can I Facebook her and see what she looks like?
No, not now. Don't do this. Okay.
That's Hunter's.
Like,
It's my
has she
stepmom.
coached before?
It's my stepmom.
Never?
Trust me, she's good.
It's my stepmom.
Yeah, I know. I know that.
Wait, is it
Tiffany's
not
a
like
good
you guys
kid.
have the same
I had
last
Tiffany
name?
as a student in
Yeah,
school,
I know.
and she'd tell you I'm a bad person probably. So, she's a good person. I think you'll like her.
Okay, I know. So who's going to be the fresh staff coach then?
Basketball god.
She is, I guess.
But if you're gone, she has to take your spot. Who's supposed to take her spot?
I don't know. I'll just try my best to be here. Okay. Anyway, let's stay focused on the task at hand. Describe the transformation of f of x equals x squared. Okay, so what family are we talking again?
The quadratic.
Okay, parent family, quadratics. It says represented by h of x equals quantity x minus 1 squared plus 2. I'm not going to make you graph this. You should know this. Okay? How is this parent function moved to form this? What kind of movements would you make? Yeah. The x minus 1 in parentheses means move what direction, kids? Right how much?
2.
Ah. Right 1 unit. How about the plus 2 on the end? What's that doing?
Up 2. Got it.
We should remember how to do that, okay? So if I say, hey, here's y equals x squared, you should be able to move it right. Whoops, I screwed that up. It should have been right how many units, kids?
1.
He actually wrote it too.
Right 1 up 2. There we go. So we've got it fixed now, right?
Yeah.
Okay. Good? Good?
That's all you gotta do?
That's all you have to do. Again, describing transformations, we should know how to do this. Now, let's take this a step further. Do you guys have what you need there?
Yes.
Okay. Yeah? No? Yeah?
Yeah.
Okay, page 2. So in this one right here, we're going to talk about transformations of quadratic functions. And it says, describe the transformation of f of x equals x squared represented by h and then graph. Okay, here's the deal. You should know what these transformations are. I'm not going to talk too much about these. Guys, take a look at this right here. Again, what's the parent function? Y equals what? X squared, right? Okay, I want you guys quickly to talk about how those are transformed with somebody at your table. Take a minute and do that, and then we'll come back together. I want to know how they're transformed. How is the parent function transformed right here to form these? Like what kind of movements are going to be made?
No.
And you might want your notes from 2.1 handy to take a look at.
Yeah. We're super smart. He came up with trapezoidal.
I think it would be
My deck is going to be the death of me.
I don't know how to say
There's
it.
holes all over. I keep thinking I'm going to fall through and die.
That's the very thought I got.
How was yours?
Oh, it's pretty good. Verticals break up for me.
It's true. There's a lot of holes that I've got right now. And I'm going to fix it.
Verticals
I have no fun.
down to.
All right, 31 more seconds.
oh wait, I was scared you guys been terrible.
All right, let's talk. Let's see if we remember this right here, kids. What's the negative sign out front going to do first? Okay, there's no parentheses, so it's just flipping over the x or y axis. Okay, so the first thing we're going to do is this, the minus sign. The minus sign indicates that we would flip over what?
Oh, that is very.
X-axis. Yep.
I would not.
I said it before you wrote it, so I got it.
Okay, what's the 3 do, kids?
Vertical stretch.
Exactly, vertical stretch. It's taking all the points and it's pulling it further away from the x-axis, so this will be a vertical stretch. So we need to remember this kind of stuff. So vertical stretch meaning how far away are you pulling the points away from the x-axis? Very good. Careful on this one. Where's the 1/4 at? It's in the parentheses. So it's out in front of the x. It's a times, so it has to be some kind of a stretch or a shrink, but since it's in parentheses, is this going to be a vertical change or a horizontal change? And horizontals are weird. They kind of do the opposite of what they think or what we think they should do. So a 1/4 right here, this is really going to be a horizontal what? Stretch. Yeah, it pulls it apart. It's a horizontal stretch. Okay, so the 1/4. And guys, what I want you to get in the habit of, like, see how I'm writing the negative right here? The negative sign does what? I want you to start getting in the habit of writing down, say, okay, the negative sign there does this. The 3 does this. You see how I'm changing this up a little bit now? Okay, so right here, the 1/4 is my what? Horizontal stretch. Right? And then we've got this -2 out here on the end. What's that -2 do?
Down to.
Moves everything down. 2. Okay. Make sense? Are you guys okay with that? All right, so if I say, hey, Tell me how the family or the parent of the family of a quadratic has moved to form new functions. Can you remember how to do that? We've done that, really, haven't we? Okay, so I think where things start getting new then is this. This is where things get new. Instead of saying how things are transformed, they want us to start doing what, kids?
Writing.
And this becomes kind of a big deal here. Okay, example 3 is pretty simple. Example 4 is really difficult. Okay. All right, how about example 3? I need a volunteer to read that, please. Okay, Liam. Sorry, Grace. I'll give you 4, all right?
Let the graph of G be a horizontal shrink by a factor of 1/3, and a reflection in the y-axis followed by a translation 2 units up the graph of f of x, which is basically the parent function of the quadratic family. Write a rule for G and identify the vertex.
Okay, so the first thing we're going to do, kids, is this. It says horizontal what, kids? Okay, so G becomes... And I should back up and write G of x. Okay, the first thing that happens here, kids, is this becomes a horizontal what? And then
Translation. Oh, reflection.
reflected in the y-axis, and then what?
Translation to
Okay, let's see if we can't figure this out. Let's figure this out. First thing we're going to have in parentheses is, am I putting 1/3 in there or not?
Yes.
Why 3? I heard somebody say 3. Because it is a... Okay, let me do this first. I'm going to write this as 3x to the what first, kids? Okay, let me go to decimals here. Okay, get rid of this one. I'm going to start out with y equals 3x to the second. Guys, does that appear to be a horizontal shrink? Yes or no? Take a look at this point right here. Negative 3, 9, right? What's the x value on that? What's the x value on this? So did that shrink by a factor of 3? Or, in other words, horizontal shrinks means it's getting closer or further away from the x-axis. So if this was at negative 3, wouldn't this be correct right here, kids? If this was at negative 3, it should shrink by a factor of 1/3 to negative 1, right? You guys okay with that? Okay, now, what was the next move they wanted? Ew, so we have to put we have to make this x a negative, don't we? Okay, when you have a reflection in the y-axis, so this is going to become the following now. It's going to be g of x. But hey, think about this, kids. Think about this. Think about this. I should have this parenthesis right here. Hang on a second. Okay. Guys, what's the 3 times 3 right here when I square the 3? Well, what's the negative x times negative x? Positive x squared. So this is really the same as what value, kids? Is that 9x squared? Okay, so I'm going to go back here. Just going to get rid of the parentheses here. Guys, is this still showing a shrink factor of 1/3? Again, if I look, what's the x value here? What's the x value here? Okay. Does it appear that this green graph has been flipped over the y-axis, meaning everything that's over here is now where?
Over there.
And everything that was over here is now where?
Over there.
So are we still good in a reflection?
Yeah.
Okay, then the last part then was to move what? How do you translate something up 2 units? What do you do to the end of it? Add what?
2.
What? 2.
Okay, so back on my graph, have we shrunk this the way we wanted to horizontally? Have we reflected it over the y-axis? Well, technically yes, because it just mirrored itself. And then I want to move it up how many units now?
2.
Okay. Did the origin that was at 0, 0 move up 2 units here? So what's your final function here? 9x squared plus 2. Okay, that's pretty tough. Now, I think example 4, I think we can make pretty good sense of, but you have to be so careful on 4. So what do you have in there for example 3? All right, example 4, you might want to put 2 stars by this one. Or an attempt at 2 stars. All right, this is a tough one. What's the original function we're starting with, kids? Okay, let me get that into decimals. This is going to be very important. In fact, what I'd like you guys to do is maybe write down by example 4 that says you might want to see decimals for something like this, okay? All right, let's just talk about this. Give me that original function that we're starting with then, kids. Y equals what? 2x squared plus... Okay, plus x? All right. Wow. There's the graph of that right here, and I'm going to take this home, like so. Guys, is the vertex right at 0, 0, or is it somewhere else? It's somewhere else. I don't know where it is, but it's like at a weird point. Negative 0.25, comma, negative 0.125. Remember that, okay? That's the original graph, 2x squared plus x. Why are we using that? Because they aren't saying you're using the parent function anymore. They're saying you are starting with 2x squared plus x. Okay, let's take what we know about transformations and see if we can't figure problem number 4 out. First of all, it says let the graph of G be a translation. I'm going to underline all my translations. What's the first one, kids? Second one is followed by... Okay, so the first thing we're going to do is go what? Okay, I'm going to write this as is first, okay? G of x would equal the original f of x, and here's how we're going to translate this. If I'm going 4 units to the left, that's like x plus 4 in parentheses, isn't it? You guys all agree with that? Okay. Then, if I want to go 1 unit down, that's like subtracting 1 inside of or outside of parentheses. Outside of parentheses. And then the last one is followed by a reflection in the y-axis. I have a question, kids. If I'm reflecting in the y-axis, what am I changing? Somebody help me remember that rule. Not negate the whole thing, but negate just the x here. Okay, negate just the x. So watch what I've done here. Why did I negate the x inside of parentheses, kids? That's the reflection in the what? Okay, why did I put plus 4 with it in parentheses? Left 4 units. Why did I put the minus 1 right there? Okay, so to figure this out, kids, we really need to do and say the following. G of x is going to equal f of, okay, you see this part right here? Oh, let me get my tools opened up. Okay, again, keep in mind, what's the original function? Okay, everywhere where you have an x right here in this function, everywhere we have an x in that function, you need to replace it with what now? Negative x plus 4, and then at the very end of that, you're going to put a what? So here's what this is going to look like. I'm going to make some room here quickly because I know I'm going to need it. I would encourage you to write kind of small for this. Here we go. G of x is going to be the following. All right, kids, right here. It becomes 2 times, what's taking the place of x now? Negative x plus, all to what power? Second, plus, what's replacing this x right here again? Negative x plus. Okay. And then, according to what I wrote up here, what do I have to have after I've plugged that in everywhere? Minus 1 at the end. Okay?
Wait, so you wouldn't need like 2
Nope, just the 1. Because f of x was this whole function right here, Jasmine. And when I plug this part in right here, when I plug the negative x plus 4 in, that's going just into this. The minus 1 is separate of everything else. Okay with that? Okay, so here we go. Over here, you guys remember how to FOIL stuff out? Remember how to FOIL stuff? Your favorite 4-letter F word? FOIL?
No.
Oh, you guys know how to do this. Let's FOIL out negative x plus 4.
Oh, is this how you do the distributive property?
Well, pretty much, yeah. Isn't negative x plus 4 that quantity squared mean take it this times itself right here?
Yeah.
What's negative x times negative x? That means do the first ones each. X to the, okay, the outsides. Do the outsides. That's the O in FOIL. Negative x times positive 4 is, okay, then I have to do the insides. Positive 4 times negative x. That's the I in FOIL. And then 4 times 4. You guys agree that this is x squared minus 8x plus 16? Okay, so this is all the following. This is now 2 times x squared minus 8x plus 16 plus negative x plus 4 minus 1. Huh, no problem. Help me distribute all of this mess right here. How many x squared are you going to have, kids? Two x to the second minus 16x plus 32. When you take that all times 2, right? You've got a plus a minus x, so that's just minus x plus the 4 minus 1. This is getting rather ugly, and that's okay. I'm going to put the final answer up top in blue. G of x will equal the following, finally. Okay, does 2x squared combine with anything I have right now? No. How about this negative 16x? Does that combine with anything? So how many negative x do we have? Minus 17x. Plus 32 plus 4. 36 minus the 1. Plus 35. Okay. Now let me show you what we've just done here, and let me try to make sense or help you make sense of what we're really trying to accomplish here. We started out with which function, kids? 2x squared plus x, to which we said let's move it 4 units left, 1 unit down, followed by a reflection in what, kids? y-axis. Okay, let's check this out. What do we come up with for an answer here, first of all? What's our new function? 4x squared. Or no, 2x squared, right? 2x squared minus what? Plus how much? Okay, let's just check this out, kids. My original vertex is here at negative 0.25. You agree with that, kids? Okay, it said move it left how much? Okay, so watch what I do. I'm going to go left 1, 2, 3, 4. That puts me about here. And then down how much? 1 unit. That vertex would be right about here now, right? Now I need to take this. Oops, I'm sorry. I'm off a little bit. It would be right about here. Ooh. Does my vertex look like it's supposed to be about that low compared to this over here? Because now I have to take it and reflect it over what, kids? Does it look like it's going to land right there? Think we've done things correctly? We move that thing left 4, down 1, and reflect it over the y-axis. That new function would be 2x squared minus 17x plus 35. Okay? Is there a lot going on there? Yes. Okay? What I'm going to back up to here, kids, is this. I think it's very important that we get used to doing the following. I think that it's important to get used to saying, okay, what are we doing to our function f? Help me out here, guys. Why did I put a negative sign with the x inside of parentheses here?
It's a reflection of the y.
That was the y-axis reflection. Why did I put a plus 4 here? Left 4. Why did I put a minus 1 out here? Down 4. Now, our function wasn't just a parent function, x squared. It was 2x squared plus x, wasn't it? So I had to replace all these x's with what, kids? What do we replace these x's with? Negative x plus 4. You understand why the minus 1 is on the end here? Okay. That's a pretty upper level problem right there. And you'll see more like that, but questions on that one right there. Yeah, Belle.
So when you reflect it in the y-axis, you just negate the x.
Just negate the x. And some people get confused. And you can't negate, because if you negate outside of parentheses like this, that's basically saying you're negating the whole function. And we don't want to do that. We just want to change the sign of the x value. Make sense?
Yeah, I just didn't know if you negated the 4 too.
Nope, just the x, kid. Good question. Now, if we were reflecting over the x-axis, then everything would have gotten flipped. But since we're going with the y-axis, you're switching it. And think about it. The y-axis is right here. If I go 2 units to the right and reflect that over the y-axis, that's going to -2. It's just changing the x value, right?
Yeah.
It's not changing where the y value lands. So, okay with that?
Yep.
Okay. Oh, this is good stuff. I love this. You get all geeked up on it. Then you have a little coffee and you get goofy with it. It's good. It's all good. Questions on this at all? Let's see if we can't model this last one. Decimals will be really important on this last one right here. Okay? Grace, you want to read this one for me? Since I took the last one that I said you would get.
The height, age, and weight of a water balloon can be modeled by h of x equals -3x squared plus 24x plus 11, where x is the horizontal distance in feet from the launch pad. The launch pad is adjusted so that the water balloon lands exactly 9 feet away from the launch pad. Write a function that models it with the new path of the water balloon.
Okay, here's the deal. This is a pretty tough question, but if I think you see things visually, anytime they start writing the words modeling like this, I might say think Desmos. Okay, here's how this works. Okay, Desmos. Ha. All right, here we go. I'm going to draw this real quickly, like so. They're saying that we have this launching pad that can be what, kids? Can be adjusted. Okay? There's a launching pad that can be adjusted. We're launching stuff off of this right here. Now you guys all know that when you throw stuff into the air like this, eventually it does what? It comes back down to the ground. It travels a certain horizontal distance, it goes to its highest point, or the vertex, and then finally falls back to the what, kids? back to the ground, okay? So in this particular example, they're saying we have a model right here. Your launch pad is going to be here, but this launch pad can either be moved up or it can be moved down for adjustment, all right? So this launch pad starts out at a certain height, h, measured in feet, okay? And they're saying that if this is where you launch something from, eventually it has to come down and hit the what, kids? Has to hit the ground, okay? That might be the best part of a curve I've ever drawn in my life. That's pretty good. Okay, this path right here would be what it takes. And this path right here is modeled by which function, kids? H of x equals what? Plus 24x, right? Okay, kids. So the question becomes this. It says, we want to adjust this pad right here so that when our stuff lands right here, maybe it hits at 9 feet right here. Okay? This is the original path, and maybe this is the path we need to take. But we're saying we want that balloon to hit exactly how far away from where that launch pad is, kids, on the ground. 9 feet. Okay, we want this to be 9 feet. So, here's what we're going to do. I'm going to go ahead and graph the original function. Is that okay? All right, let's get into decimals. You guys, tell me what the function is that they give us again. Y equals what? Was it negative 3x squared, kids? Okay, negative 3x squared plus 24? Okay, and then what? Plus 11. Okay, let me zoom out on this a little bit. So here comes my Team Umi zooming. And I don't like that. How about, I like this, okay? So I'm going to pick some points on this quickly. All right, here's the deal. 0, 11 is where we start. We're 11 feet up, and it's going to take this path right here from 0, 11, and eventually it's going to return to the ground right here. Okay? Now keep in mind, I can't have negative distances. So they're saying that this path starts up here at 11 feet. If I would launch according to this path right here, how many feet did that go? 8.435. So is that path going to get your landing 9 feet from the launching pad? Or 9 feet from right? Okay. So what do you think we're going to have to do to that launching pad to get more horizontal distance? Well, my question is, do you think we're going to have to add some more, subtract some more? Are we going to move the launching pad up some more to get more horizontal distance? What do you think? If I stood on top of this table and threw out something, or if I stood on top of the school and threw out the same path, which one's going to go further horizontally? Standing on a table or standing on top of the school? Why? It's going to be an air longer, right? Let's take a look at this right here, kids. We wanted that to fall exactly at what, kids? We want the x value to equal 9. So watch what I just did here. I typed in, I want this x distance to be equal to 9. And if you notice right here, kids, I had this 9 line, it's pretty close to this 8.435, but not exactly. Watch what I'm going to do, though. I'm going to come down here and say, you know what? These 2 points actually cross somewhere. They cross at 9, what? If I could take this graph and shift it up how many units? 16 units straight up. Wouldn't this point land right there at 9 then? Okay, so by looking at the graph right here, when I put x equals 9 in here, and I'm going to write that by putting x equals 9 in here, we see we could shift the parabola up how many units? So if I would add 16 to my original function right here, kids, adding 16 to this original function It's not going to change this, and it's not going to change this. What it is going to change is the 11, though, right? By adding 16 to that, what's this become?
27.
So we get new function to be and I'm going to call it g of x equals negative 3x squared plus 24x plus 27. So we're going to adjust this up. Let's just check this out, kids. What was it again, Shirk? Plus 27?
Yep.
Here's my green graph now, kids. Oh, what happened here? There we go. Where did it land at, kids?
9.
Right at 9 there, okay? I'm going to get rid of this blue line here. We are right at what? 9. Are we 9 feet away from the launch pad?
Yeah.
We had to move it up a little bit. How many units do we have to move our launch up? 16, okay? So keep that in mind. I sent out the new online. If you could take a look at that, that'd be great, but it's not going to be due until Wednesday. So see what you can do with it.